Okay, lecture 46 notes, 3 more hypothesis testing for the mean examples. All right. I am experiencing a little bit of technical difficulty. My clicker is not working. I have these laid out so we can zip through them real fast with PowerPoint, but let me just try one more time. No, it is not working. So, and maybe that's a good thing because I was going to stand here and kind of talk you through the power slides, but I can't do that. So what I'm going to do is I'm going to introduce the first problem. Then I'm going to run around behind the camera and I can manually click through the PowerPoint and bring everything up and you can see the problem get worked, okay? And then once I've done that, I'll probably come back around, make a comment or two, and then we'll look at the next problem and I'll have to go around behind and run through it and then do the same thing for the third problem. So sorry, this is kind of nuts, but I can't wait any longer and we got to get this going and I don't know when we'll get the clicker fixed. So yeah, so what I want to say is my plan here is if you look on the first page, it has the problem laid out with 1, 2, 3, 4, 5 problems, or parts, I mean. What you ought to do really is pause me right now, read the problem, and then see if you can work it all the way through. I'm hoping with the other examples you have and other work you've done, you should be able to zip through that. But if you struggle at any point, then do what you can do, and then I'll catch up to you with the PowerPoint, and then when you get to where you can kind of figure out where you're stuck, pause me again and see if you can work the rest of it. Okay, so I'm going to walk around behind, and you won't hear my voice because the microphone is right here, but I'm going to be all the way around behind. But I will just step through the PowerPoint fairly slowly. And you'll have time to pause it and try to work on ahead if you can. And that's the best thing. If you can get it worked without my help and just use my help where you need it, right? Okay, so I will walk around behind. Well, let me read it first. Okay, so the average length of time an adult spends exercising in 1 week is under 60 minutes. Okay, that's the claim. We're going to test this claim by surveying 100 adults chosen randomly. And we do that and we find the mean time they spend exercising in a week is X bar equal 56 minutes and the sample standard deviation is S equal 14 minutes. We'll test at the alpha equal 1% significance level. Okay, that's all you need to know. You ought to be able to just zip through the problem here. Let me just start off saying, hey, 100 is bigger than 30, so central limit theorem kicks in and everything should be fine, right? All right, I'm going to go around and I'll put up the null and alternative hypotheses, which you should have figured out. Then I'll put up the sketch of the curve and have the rejection region, all that stuff in it. Then I'll put up the computation of the test statistic, and then we'll see whether we should reject or fail to reject, and then we'll see the final conclusion. Try to do it before I do it. All right, I'll be back in a little while. Well, okay, let me come around and make a little comment here. So I'm hoping, like I said, you paused me where you could and you've figured everything out on your own. I used degrees of freedom equal to 100. My table didn't have, it was 100, sample size 100. My table didn't have 100 minus 1, didn't have 99. So I used 100. As I said before, sometimes people say you should use slightly smaller degrees of freedom. Let me very quickly say that if you do that, what that does is it tends to push your critical value out a little bit more. And in a sense, that maybe makes you a little bit more honest because it makes it harder for a test statistic to make it out far enough to be considered unusual, right? If you push the critical value a little bit more by using a lower degree of freedom. So people will say to have integrity, since it was 99, you should drop down to 90 if that's what's in your table. But the truth is, first off, it's so close to use 100 or 90 that it really isn't going to matter. And the second thing is that when you do a problem like this in the real world, you're probably not going to use tables, right? We are using tables because we're learning and understanding what's going on. But you're going to use software, and that will use a calculus-based algorithm that will actually calculate much more closely what the correct t-score is, or whatever, for the correct degrees of freedom, 99 in this case. So it's not really that big of a deal. I'm just going to go ahead and use the closest one, which is 100. Okay, so I did that, and what we found is the test statistic certainly was over here in the rejection region, right? It's to the left of negative 2.364, which is the critical value. All right, so we reject the null hypothesis. What does it mean to reject the null? Remember, we always reject the null or fail to reject the null. Never do we speak in terms of rejection or failing to reject the alternative. The null is 60, mu is equal to 60 minutes. So at the 1% significance level, since we're rejecting, we have sufficient evidence to reject the claim that adults spend on average 60 minutes. That's what the null says. All right, now we can add to that. Once we understand that, we can say it appears that they spend less time. It appears that we might want to embrace the alternative hypothesis, right? Okay, let me rub this out. And I'll go ahead and read the second one here. The mean credit card debt carried by a typical consumer is over $6,000. Monthly credit card debt is what I meant there. We will test this claim at the 5% significance level. We survey at random 64 consumers and find the sample mean of credit card debt is $6,300 with a sample standard deviation of $1,600. So it's more than $6,000, but is that more than $6,000 just due to the randomness in picking a sample, or does it really indicate that we're wrong about the $6,000, right? That's what we're after here. Okay, and I don't even write the outline there, but you know what it's going to be. It's got these 1, 2, 3, 4, 5 parts. So let me say here, I said my table had degrees of freedom 60, so I went 64 minus 1 is 63, so I just went down to the closest, which was 60. Let me go back around and just step through that one then. Be back in a minute. Okay, I hope you're able to do all that on your own. So the, let's see, where is it? There it is. The test statistic is not in the rejection region. It's somewhere over there. Actually, probably, closer, but it's not in the rejection region, right? It's a little too small. It's not extreme enough. Okay, so we are going to fail to reject. And what is the null? It's that the mean is 6,000. So remember, the original claim was it's more than 6,000, right? But what we are going to reject, or in this case failed to reject, is the null, which is that it is 6,000. So at the 5% significance level, we have insufficient evidence to reject. We fail to reject the null, the claim that the mean credit card debt is $6,000. We don't, and so that's it. We can add, we don't have strong evidence at this significance level for claiming that the average debt is higher, right? It's 6,300, but that's not strong enough for us to say that we believe the mean debt is higher. So we cannot reject that it really is just 6,000. Okay, so we are failing to reject the null, and we are not feeling real confident about embracing the alternative. One more, and I'll go ahead and read it. Okay, you are a statistician for High Times Drug Company. High Times has developed a new drug called Dental Gloss that causes your teeth to glow in the dark. Isn't that cool? The problem is there are reports that dental gloss causes erratic swings in people's weight. You are asked to run a study in which you must determine whether there is good evidence to believe that dental gloss may cause this, may cause people's weight to vary. Since your company hopes it doesn't, of course, you are told, or at least that your test will show that it doesn't, you are told to use a low value for your significance, 1%. And this is often how people operate. Let's make it really stringent. Let's make it really hard for the test statistic to get out into the rejection region. All right, we don't want to believe there's any change here, right? Because that could hurt our sales. You give the drug to 144 randomly chosen people, and after 8 weeks, you probably should say that this was supposed to be over an 8-week period. But anyway, after 8 weeks, you record a sample mean drop in weight of 21 pounds with a sample standard deviation of 18 pounds. Ken High Times claimed that there is no evidence that dental gloss causes people's weight to fluctuate. Of course, the weight fluctuation could happen just on its own, right? But just by random fluctuations. But is this enough of a fluctuation that we think there really is something going on causing people's weight to change? All right, so I'm going to go back around and I'm going to put up the whole thing. We're going to start with the null and alternative hypothesis. Very much think hard about what the null hypothesis is here, okay? I don't want to say it. I'll go back around. I'll put it up and I'll just go through the whole thing. But before you do this, really try to figure out what the null hypothesis is. I tell you, no change, right? Null means no change. Here I go. Okay, I'm back. Let's see. What do I want to say here? First off, it's two-tailed, right? Because the null hypothesis, no change, would mean we'd expect that there would be no weight change, right? So the mean weight change, if what we are measuring here is weight change, and I probably should say that up here, I didn't, but you might want to stick in, if what we're measuring is weight change, then we hope the mean weight change is 0, all right? So since we're not saying it increases or decreases, just saying maybe there's a fluctuation, the alternative is that it is not 0. So it's two-tailed. The significance level is 1%, which is 0.01. Since it's two-tailed, I break that up into 2, and I have 0.5% here and 0.5% over here, right, area. And I used, let's see, n was 144, n minus 1 was 143. I had to go down to 100 in my table. Excuse me. Okay, so, by going lower, I'm know that I have good, strong critical values, like I said before. Test statistic is just way the heck out there, right? It's way out there, too far even to put on the picture. So we're going to reject that null hypothesis. We're way out in the rejection region. Okay, so finally, at the 1% significance level, we have sufficient evidence to reject the claim that the mean weight change for people using dental gloss is 0 pounds. Another way to say that would be, we have sufficient evidence to reject the claim that people's weight doesn't change, right? That's that the null hypothesis is saying. So it does appear that there's some non-zero weight change. Here it looks like a drop in weight, right? But what we're just showing is that there does appear to be non-zero weight change. All right, I will stop here. I just want to say that in this example, it's a little bit contrived because really typically the way that you would maybe do this is you would compare two groups. You would compare a group of people who would be called the control group, and we'd look at their weight change over 8 months, and you'd think that would be 0, but you don't know for sure. It could change a little. And then we would look at the weight change of people using dental gloss over the same period of 8 weeks, whatever. And then you'd take their difference, right? You'd look at the mean for one and the mean of the other and take the difference and try to decide if that was indicative of some sort of change, or if it was just maybe whatever difference was due to random fluctuation. That is where we're actually doing what we call a difference of means, and we're going to talk about that probably next week. I don't think we'll get to it this week. That's maybe a little more realistic way of doing a problem like this, but what we did here makes sense, right? If we're just assuming that there would be no change, and then look, using this stuff does seem to give you some kind of a change, so we get to where we reject the null. All right. Sorry about having to run back and forth like that, but we'll stop here.